Hi there. Welcome to the onboarding journey at Outlier. My name is Akshat and I am going to take you through this entire onboarding course where I will make sure that you're equipped with the right knowledge and the tools to succeed as a contributor at Outlier. So before we begin, let me give you a brief about what Outlier is and what is it exactly that we do. At Outlier, the core of our operations reside in the data that is being used to train these state-of-the-art AI models. We connect experts like yourself to these big AI companies that want to improve their models using your knowledge. So basically, you share your expertise to these AI models and then help these AI models become better and better over time. Take, for example, the difference in the capabilities between OpenAI's ChatGPT 3 versus latest state-of-the-art models that OpenAI has just released. This absolutely huge difference in the capability of these models is not only just a factor of how many GPUs OpenAI has used to train these, or if they've used better algorithms to train these models. The data that is used to fine-tune these models is a really important and possibly the most dominant factor in increasing the capabilities of an LLM model. This happens when you share your expertise with these models that you have gained over the years, and you teach these models how to do what you do. Now, when you join the Outlier community, not only do you get to work alongside with a lot of like-minded individuals, a lot of experts like yourself, you also get the flexibility of working from whenever and wherever you want. And as a bonus, you also get to be one of the driving forces in this race of AI evolution by making these models more and more capable. This helps make AI more human and possibly better than all of humanity combined. This is one of our goals in the AI space, which is to create what we call as an AGI, or an artificial general intelligence. AI is literally shaping the future of our world in more ways than we can imagine. Just to give you a brief picture about what is going on in the AI space right now, this is the market cap of NVIDIA before ChatGPT came out, and this one is after. This huge spike is all because of the emergence and advancements that these LLMs have accomplished. Since then, all of these big companies, including Google, Microsoft, Apple, OpenAI, Anthropic, Claude, Perplexity, all of these companies are in a race to create the most capable AI solution possible. Now, one of the main things that they need to do that is, of course, the data itself. And that is where Outlier comes in. So let's talk big picture stuff. Let's talk about what exactly is a large language models. So all of the chatbots like ChatGPT, Gemini, etc., that you interact with on a daily basis, at their very core, they are what we call as large language models. So there was this huge breakthrough in the field of AI back in 2017 with a paper titled "Attention is All You Need." So this paper actually laid the brickwork of all of these big AI models that we see right now. And by the way, LLMs fall under a category of AI that we call as generative AI. Generative AI currently has a lot of different applications, from LLMs to models that create images, videos, audios, etc. The reason why these models are able to generate this is because while training, these models go through absolutely massive amounts of training data. They learn patterns from that data, and it could be text data, by the way, it could be image data, it could be videos, audios, etc. So they learn from that particular data. They use those patterns to predict, for example, the next word in a particular sentence. So let's take an example. So given this particular base sentence, the cat sat on the dash. Now, all these LLMs do is that they create a probability score for each and every word in the English language, such as this. Now, in order to choose which word comes next, sometimes these models might choose the most probable word, which is Mac. Sometimes they may choose the second most probable word. Sometimes, based on what their internal algorithms is, it could choose from, one of the top 5 most probable words. So let's say this model chooses the most probable word here, which is mad. Now the model essentially adds this particular word to the original sentence, and then it uses the same probability scores to predict the next word. And this is how models are able to create entire sentences, entire paragraphs. Now let's look into how these LLMs are actually trained. Now, this is really interesting. There are 2 phases of LLM training. First is what we call as pre-training. So this is where an LLM model goes through all of the data of the internet. This includes your articles, your books, your scientific journals, your GitHub codes, Wikipedia articles, etc. So companies usually have this huge amount of internet data collated together, and these models then go through all of this internet data. They memorize as many patterns as they can. It gathers as much information as it can. And after that, what we have is what we call as a baseline LLM model. Just to give you a picture of what this pre-training dataset looks like, this is one which is called Fine Web pre-training dataset. Now, this dataset consists of 15 trillion tokens, and it takes 44 terabytes of just raw text space. This is basically a huge chunk of the internet itself. Now, this one is actually open source, and I can show that particular dataset to you as well. So this particular dataset consists of text file in literally each and every topic on the internet, from technology, scholarship, film festival, politics, philosophy, etc. So each and every company, by the way, have their own versions of this types of dataset. I'm not saying that they use the same version. They have their own web crawlers scraping through the internet, getting the data from maybe certain verified sources, etc. This is one of the very few open source versions of this type of dataset. So we have gone through the pre-training part of it. Now let's discuss what happens in the post-training. So after a particular model is pre-trained through all of this internet data, what we have is what we call as a baseline LLM. So these LLMs are not really good. Imagine, let's say GPT-2, for example. So GPT-2 was good at generating text, but it wasn't very accurate. If you ask it to generate even a slightly complex piece of code, it won't be able to create that code accurately. So in order to improve these LLM models, we enter the post-training phase, where we give these models certain specialized structured data, which you call as SFTs, RLHF, evals, etc. Now, the models learn from the structured data that we provide, and they are fine-tuned on this particular type of data. This increases the model's capabilities even further. Just to give you an example, a baseline LLM here can generate text from a particular context, like we saw earlier. So from a particular phrase, let's say if you ask the model a particular question, the model will not know it has to answer that question. The model might just end up expanding the question itself. So we need to teach these models that they have to answer that particular question, which is where, we fine tune them on very structured question answer pairs, or what we call as prompt response pairs. So when the model goes through a lot of these prompt response pairs, they understand that given a particular question, I have to answer it in such and such manner. So the model becomes capable of answering these questions rather than just like simply generating text from a sentence that we provided it on. This is the role of post-training for an LLM. In the next video, we will look into what these different types of data are.